Okay, we're going to look for two equations of the line. So there's going to be two equations. They're linear equations of the line that are tangent to the curve. Here's our curve. Y equals x squared plus x. And then they pass through this point to -3. So when we read this, you might say there's two equations that go through that particular point. And the answer is yes. I'm going to call that x1 for now. So if you notice, this is a little different than the others. The curve is given here. It's a parabola. It's a bit different because the point is actually not on the curve. So you have a point that is off the curve. And what they're saying is there's going to be two equations of the line that pass through the point to -3. So we have two tangent lines. Okay, so I want you guys to understand that there's going to be two tangent lines. I've already done this question, and in Desmos, I'm going to share with you guys exactly what they're talking about. So what they're saying here in Desmos is that location 2, -3, that is off the curve, has two tangent lines on the curve. One at this location, by the way, at -1, 0. And then one at, believe it or not, I believe, around here at 5. Okay? So I'm going to show you how I actually got these two equations. But that's essentially what they're saying. There are two equations in the line tangent to the curve that pass through the point to -3. So let's take a look at the calculus and the algebra. How did we get those lines? Now, generally speaking, when you find that tangent line, this is the point slope form that we're going to be looking at. So the x-coordinate and the y-coordinate of that one and only point is given to us. So now we have y minus a -3 is m tangent x minus 2. So you get y plus 3 is m tangent x minus 2. And this is the general approach that we've been using to find that altangent. Now there's going to be two of them. So far so good. Nothing's really new. I also want to note, so you guys know, by the way, what we've been also doing is getting m tangent. So m tangent, recall, is the derivative of y evaluated at some x equals, maybe I'll put x naught here. Okay, for some x value. So this is how we get our m tangent, and if we can find m tangent, I guess we could get these two equations of the lines. There's going to be two, like I've showed here in Desmos. There's going to be two. And we're going to find those two lines. So, okay. Now, here's the deal. I also want to mention to you guys something about a little bit of algebra. Now, how you really approach this, I think I'm going to use, I'm not sure what color to use. I'm going to say this. We're going to let in gold, I guess, or maybe purple, because we're going to do some algebra. Let this be some arbitrary point x, y. Maybe even call it, an initial point, x naught. So this is an arbitrary point, x, y. And that point is also represented as x, comma, x squared plus x, because this is what y equals. They told us y equals here x squared plus x. So this is an arbitrary point on the curve, and I'm going to try to find m tangent. But remember, if you had a tangent line And the first tangent line, maybe I'll use the location. This is still the arbitrary xy. But remember, over here, if you look at Desmos, there was a point that it went through, 1, 0. If we take a close look, okay? So what I'm going to show you guys is this. This is how we really do this. You need 2 points, ladies and gentlemen, 2 points to find a line. So if I can try to fix this, I don't know if I could. Maybe it's not so easy to fix, but I'll just do it this way here. Okay. You know, there was one of them, by the way. But the point I really want to make to you guys, to get this particular slope, we have to use the slope formula. Okay, so we're going to use the slope formula here. 2 points on a line, we can find the slope. And so that's kind of the idea that I'm approaching here with this. But I just did a different point for you guys here. I use this arbitrary x, y naught. So I just want to kind of go back to that idea. So here's what I'm saying with the algebra, right? Any slope requires 2 points. This is your slope formula. Okay, so if I'm going to find a slope in general, this is the slope formula for a line. 2 points to find a line. So I'm kind of actually just looking at this idea, but this isn't a tangent. Okay, so I'm just going to go back and remove that just to kind of arbitrarily let you guys know that I'm trying to find 2 points, you know, I guess a line through a point on the curve and through the point out here at 2, -3 kind of idea. So just to kind of express that to you guys, we have to look for 2 points, I guess. And I gave that really as x naught, y naught, and this is what we're going to use. This is the key. 2 points give you a slope. We're going to use the slope formula. So I'm just going to kind of clean this all up here for you guys to observe. And let's get to work now. We're going to find that particular formula here. So in general, we're going to use y, and I guess I'm going to have to change some of this stuff. Okay, I'm going to have to change this on you guys. I'm going to call this in this formula, well, we can call this 1, we could call this 2, or why not? The reason I'm doing that is because I'm going to get that slope, meaning y minus y naught. This is the x and y value. The -3 over the x minus the 2. So I'm just going to use the slope formula here for the coordinate 2, -3, and any arbitrary point on the curve. And this is where we're at here, ladies and gentlemen. So simplifying this, slope will be y plus 3 over x minus 2. Okay? So that's going to give me a slope for really any point on the curve and the coordinate 2, -3. But if you said, I want that to be m tangent. We want that m to be m tangent. Well, okay, that's going to happen for a particular point on this curve. M tangent is found, and we're going to use this. I guess we can keep it that way, x naught, okay? We're going to remember that if we want that slope to be m tangent, and we do, we're going to take the derivative of y. So that m tangent becomes the derivative of y, which is the x squared plus x, evaluated at that point on the curve. This becomes 2x plus 1, evaluated at that point on the curve. That gives you a tangent. And we're using the right notation. It's kind of x naught, I guess, but, let's get rid of that so it's kind of not confusing. So here's what we want to know. This is going to happen for some of that x value there. So to have m equal m tangent, what this really gives you here, here's your m slope, here's m tangent right here. We set those equations equal to each other, meaning y plus 3 over x minus 2 has to equal 2x plus 1. Okay, just going to double check to see if everything's okay. And now that says y plus 3 is 2x plus 1 times the x minus 2. But recall what y really is. Y is our x squared plus x plus 3. And that's going to equal this 2x plus 1 times x minus 2. Now, this is a quadratic. We have to solve this quadratic for x. You can use beginning algebra to solve this. So when we used to teach beginning algebra, we used to teach how to solve these particular equations. By FOIL here, you get 2x squared, first outer term, minus 4x, inner term, plus x, minus 2. So simplifying the right-hand side, we get 2x squared minus 3x minus 2. Okay, subtract x squared, subtract x, subtract 3, we get 0 equals x squared minus 4x minus 5. So using beginning algebra to solve a quadratic. Okay, I like putting my 0 on the right side. So we're going to factor. If you want to use the crisscross method, we need two numbers whose product is -5 and whose sum is -4. Those two numbers are going to be -5 times, let's double check, not negative, yeah, -5 times +1. If we multiply those numbers, it's -5. If we add them, it's -4. So those are the numbers. So this is x minus 5 times x plus 1 equals 0. Those are the numbers I'm looking for. All right. Okay. By the zero product rule, x minus 5 equals 0. X plus 1 is 0, which means x equals -1. X equals +5. So those are the two numbers. So we found the x values, ladies and gentlemen, on this curve here. This is why x is -1 over here. So you said, oh, at -1 we have a tangent, because that's where m tangent is. And also over here, we can't see it with this picture. But at x is +5 now, you're going to have the other tangent. So we got the x values, okay, -1 and +5. And that's kind of what we want to use here. So the question now is, okay, what is m tangent for these two numbers? Well, m tangent is y prime, which was the 2x plus x, I believe here, when x is now these two numbers. So if we try x is -1 here, we say, what's our m tangent? Well, when x is -1, 2 times -1 plus -1, I double check here, Okay. These are the values. Let's double check everything's okay. It looks like it's okay to me. So it looks like this is a -3. So m tangent is -3 here. That happens when x is -1. Let's double check. X squared plus x. I think we're, oh, no, let me be careful here. We're wrong. It's going to be here. It's not, it's 2x plus 1. Yeah, that's where my mistake was. Okay, this is plus 1. Okay, don't forget m tangent. So that's where I'm kind of having a little trouble here. All right, now we're good. Okay, so remember this. Let's highlight this here. 2x plus 1 was m tangent. Yeah, right here. Okay, I'm just putting this notation, I guess. Okay, 2x plus 1. Now we're good. So this is going to change our answer. We're going to get -2 plus 1. So my m tangent is -1. And that happens when x is -1. So if I go back to my equation here, like we were looking for, this original equation for altangent, this is the first altangent. So, okay. Well, we found altangent, our m tangent. It's -1. So this will give us the first equation. There it is. So that's the first one. It's -x minus 1. So if I go to Desmos, this is my point here. Okay? That is the first equation that has a tangent line and it goes through the coordinates to -3. And that's what they're asking. But there's two of them. The other is when we use the x value of 5. So we're going to do the same thing now. We're going to use the x value being 5 now. So I'll plug it in here. So I guess we'll put it down here when x is going to be 5. We get 2 times 5 here plus 1, and that's going to give us 11. So m tangent, 2 times 5 plus 1, m tangent is 11. Y minus, go back to that equation. We found m tangent here. So we're going to go back to this point slope form. I want to copy that. Let's copy it. So do the algebra. So let's double check. Oh, it's 11. Sorry. Plugging in that 11. Okay. I'm getting too excited. It's almost done. All right. So this is going to give us 11x minus 22. So I subtract 3. 11x minus 25. There's your equation. 11x minus 25. And in Desmos, I already did the work. And as you guys can see here, 5 is somewhere up here. But that's the answer to this question. So let me do something here. I'm going to import it just so it's complete. And there you go. So let's get this here. And you have found two equations. Tangent to the curve, y is x squared plus x, that pass through a point 2, -3 that is off the curve. And these are the two equations. Y is 11x minus 25, and y is -x minus 1. There we go. Here's the two equations. So I hope you guys enjoyed the demonstration. It was a fun demonstration, but it does go back to beginning algebra. Remembering the slope formula.